SpiralTrac is a new generation of throat bushing that is used in seal chambers of industrial pumps and rotating equipment. It allows you to reduce or eliminate flush while increasing the mean time between repair. To understand how flush can be eliminated, we first have to understand why it's been required. Flush has been necessary because air traps in the seal chamber, fluid circulation and exchange are restricted in normal seal chambers, and centrifuge traps abrasives in the cavity. First we will look at how air traps in the cavity and why it makes flush necessary. When the pump is flooded, the air at the top of the seal chamber cannot escape. In crystallizing fluids, even when the pump is stationary, this air can cause a problem. The presence of the air allows crystals to form along each side of the mechanical seal. This can cause hesitation and leakage on startup. Air is lighter in specific gravity than the fluid, so when the pump starts, air is driven by centripetal force to surround the shaft and the mechanical seal. Since air is an excellent insulator, seal face temperatures can increase dramatically. Elevated seal face temperatures can directly affect O-rings and face materials and cause different products to harden, polymerize, crystallize, or exceed vapor margins. Seal face temperatures are critical in acid surfaces, where every increased degree can increase the aggressiveness of the acid. All of these factors can shorten seal life. So one of the reasons for using flush is to push some of the air from the seal chamber to allow seal face temperatures to be controlled. SpiralTrac incorporates a special vent design that resists plugging during operation of the pump. This vent, located at the top, prevents air from trapping in the seal chamber and avoids one reason for having to use flush. We want to emphasize, however, that air can also enter the seal chamber from another source. If the product is aerated or the pump is run dry, some of this air can be driven down the back plate and into the seal chamber. In this case, flush will protect against some of this process air, or you can use quench, double seals, or use suction from the seal face. The second reason that flush is required in a normal seal chamber is that fluid circulation and exchange are restricted. The throat at the bottom of the cavity prevents any fluid exchange in and out of the chamber, and the narrow cross-section restricts fluid circulation around the seal. The combined effect is to again elevate seal face temperatures. Even with the chamber properly vented, the seal face temperature rise is still excessive. In a regular seal chamber, flush helps to cool the seal faces by forcing a circulation around the seal and to drive an exchange in and out of the cavity. Unlike a normal bushing, SpiralTrac forces an exchange of fluid into and out of the seal chamber and drives the circulation continuously around the seal for seal face cooling. The flow patterns generated by SpiralTrac augment or replace the requirement for flush to perform seal face cooling. The third reason for flush is to prevent abrasives from entering the cavity. Any abrasives in the cavity are forced to the bore by centrifuge and then towards the ends of the chamber by the axial flows driven off the back of the seal. Once in the chamber, abrasives cannot escape. Theoretically, flush is used to create a high velocity under the throat to inhibit entry of abrasives. With abrasives, the open bore concept can lead to severe erosion. The major flow pattern is driven along the rough exposed back of the impeller down the bore towards the seal face end. It returns along the seal and the shaft to cycle again. Any abrasives in the region will be centrifuged to the bore, where the flow drives them to the seal face end, They cannot return along the seal with the flow because centrifuge simply drives them outward again. As a result, they rotate at the seal face end until they wear out, something else wears out, or the seal fails. This erosion and seal damage can occur even in the vertical configuration. The velocities are so extreme that the abrasives are instantly driven upwards. We know that abrasives centrifuge outward, so with SpiralTrac, a computer-profiled spiral groove generates a flow pattern drawing from the bore. The abrasives are captured, concentrated, and fed to the exit groove for removal. This 1/10 speed slow motion shows how effective centrifuge and the flow patterns can be. If the exit groove continues all the way through to the impeller side, no flush is required for this removal. The seal cavity is a very efficient centrifuge and will even separate paper stock. This allows SpiralTrac to reduce the percentage of paper stock in the seal chamber. This prevents stock dewatering and ensures proper cooling for the seal faces, as shown in these pictures. This sequence takes approximately 1 minute and is included in its entirety at the back of this video. To review, SpiralTrac reduces or eliminates flush because the air can be vented, fluid circulation and exchange are forced, and abrasives can be drawn from the cavity immediately. To accomplish all of these things, both the exit groove and the air vent must extend all the way through from the seal chamber to the impeller side. Several installation configurations are available, but only the Type I fully incorporates the air vent and the exit groove. The other installation types require some form of modification, or a small flush will be necessary. In this example, the backplate is machined and the SpiralTrac Type I arbor pressed into place. This phosphoric acid application can now be operated without a flush. At the opposite end, the Type B can be easily pressed through the chamber to rest against the cast-in throat. It will collect and position abrasives so that the smallest flush will push them under the throat. However, if abrasives are to be removed without a flush, then the exit groove must be extended, and the air vent extension will have to be drilled. The exit groove in the installation Type A fully extends through to the impeller side. Drilling of the 5/32 or 3 mm air vent hole is highly recommended, whether flush is to be used or not. In this example, a SpiralTrac version D installation Type A was pressed into position through the chamber, and an air vent hole was drilled. This pulp mill effluent pump was operating with 10 gallons per minute of flush into packing. Now with SpiralTrac and a Chesterton 442 split seal, all flush has been removed. The installation Type S is designed to be installed with split seals while the pump is still in place. This means that the exit groove and the air vent extensions cannot be done, and that a small flush is necessary. With regular split bushings, any abrasives from the mill water or from flooding of the pump accumulate in the chamber because centrifuge drives them to the bore. With SpiralTrac split bushings, Abrasives are continuously drawn from the bore and removed with the smallest of flush. In this 3 to 4% paper stock application, seals were failing every 2 to 3 weeks, while using over 10 gallons per minute of flush. The problem was solved with the installation of a split SpiralTrac and a Chesterton 442 split seal. Flush was reduced to 5 to 8 gallons per hour, and the seal was still running after 4 months. SpiralTrac is also available in a packing version. This version is split and installs into the chamber, replacing the 2 bottom rings of packing and the lantern ring. SpiralTrac P incorporates a system of tangential injection holes which pre-rotate the fluid into a centrifugal separation chamber. Abrasives are driven towards the SpiralTrac groove where they are collected and expelled. A high-quality packing is recommended to control leakage to drip rate or better. These are 20 by 20 by 42 GIW slurry pumps, handling 40% silica sand. The packing was lasting about 3 weeks, using 18 gallons per minute of flush. The sequence shows the typical steps of installation on the 8.5-inch shafts with 1-inch packing. The flush has been reduced to 3 gallons per minute, and the packing life is now exceeding 4 months and running. 4 of the 6 pumps have been converted, with the final 2 scheduled next. In the pulp and paper industry, SpiralTrac P has been very successful in pumps, agitators, refiners, repulpers, and other rotating equipment, all at extremely low flush rates. This clip is added at the end because it takes about 1 minute. It shows a SpiralTrac D Type I removing paper stock from a seal chamber without flush. Version D designates a special spiral groove designed specifically for handling paper stock or fibrous materials. At first, the entire seal chamber is full of stock. After about 45 seconds, the outline of the seal and the shaft will become apparent. SpiralTrac cannot remove all of the fibers, but will prevent accumulation and dewatering of the stock. This ensures circulation and cooling of the seal faces for proper seal operation. Many split and unsplit seals have now been running for over 2 years without flush in up to 6% stock.